Hello, my dear students. Welcome you all to Sri Jain Rank Zone classes. I'm your mentor and your friend for the subject chemistry. And today I will be starting with the second part of general organic chemistry apart from nomenclature. As we have discussed in the previous video, we are going to start with reaction intermediates, types of bond cleavage, and the problems related to the stabilities of the reaction intermediates. So let us start with bond cleavage. The first slide, bond cleavage. In simple terms, bond cleavage, it can directly be stated that it is a process in which there is breaking and formation of covalent bonds. Okay, organic reaction, it is a process in which breaking and formation of covalent bonds takes place. Okay, so bond cleavage is directly related to the breaking of covalent bonds. Breaking of covalent bonds. Okay, now the chemical species which are more reactive, which causes the change, which are responsible for the change, they are known as reagent. Known as reagent. Okay. So for example, we are having a reaction. This is the substrate or the reactant. It undergoes a nucleophilic substitution reaction, which is the type of reaction to form alcohol. Br minus is the leaving group. Okay. OH minus is the attacking group. The attacking group which makes the change, which brings out the change, is also known as reagent. And these are the products. Okay, now breaking of covalent bond is known as what? Bond cleavage. Okay, it is of two types. It is of two types: homolytic and heterolytic. Homolytic bond cleavage leads to the formation of free radical as the main product, and heterolytic, they leads to the formation of cation and anion. Means to say, both homolytic and heterolytic bond cleavages, they will give rise to two different types of reaction intermediates respectively. On the basis of type of cleavage which is involved, these are the reaction intermediates. Okay, heterolytic gives what? Cation and anion, and homolytic gives what? Free radical. Now, homolytic fission or homolysis, The covalent bond is broken in such a way that there is an equal distribution of electrons, right? Means bond is broken with symmetrical distribution of electrons. Okay, bond is broken in such a way which results in the symmetrical distribution of electrons. This results in the formation of odd electron species known as free radicals. Okay, odd electron species known as free radicals. So free radical is a type of reaction intermediate, as I have already told you. Okay. Reason for homolytic bond cleavage is the electronegativity difference between atoms. The electronegative difference between atoms is zero or minimal, very less. So there is no shifting of electron density to a particular carbon or any other atom. Okay, this is the bond. The shifting is done by half-headed arrow. Half-headed arrow. This is odd electron species, which is free radical. Understood? Homolytic bond fission takes place in gaseous state. Okay, or in the presence of non-polar solvents. Because in gaseous state or in the presence of non-polar solvents, the molecule is having its own original force of interaction. Maybe it is a van der Waals force, London dispersion force, dipole-dipole interaction, whatever it is. So the homolytic bond fission takes place between the bonded atoms which are having very minimal electron density, or they are of identical electronegativities. So that is why the bond cleavage is very goes very easy in gaseous state, because in gaseous state the homolytic molecules, or these what should we say, the homoatomic molecules, they have only one type of force, that is a van der Waals force or any other type of force, whatever they are having. Okay, so the types of forces, they are very less in comparison in cases of non-polar solvents or in the gaseous state, and that is why the bond cleavage becomes easy. Non-polar solvents like carbon tetrachloride and carbon disulfide. Understood? This is homolytic bond fusion. Then comes heterolytic bond fusion, also known as heterolysis. Okay. In heterolysis, the covalent bond is broken in such a way bond is broken with unsymmetrical distribution of electron densities between bonded atoms. So the covalent bond is broken with unsymmetrical distribution of electrons between bonded atoms. Okay. The bonded atoms give rise to either carb cation or carb anion as a reaction intermediate. The electronegativity difference between bonded atoms is greater than 0. Okay. In one is less negative, one is more negative. Okay. The one which is more negative means more electronegative will shift the electron density towards itself and becomes an anion. Okay. Like B is more electronegative, so it will both the electrons pair will be shifted to B. Okay. And it will be A plus B minus. Understood? If carbon is having positive charge, then it is carpetine. If carbon is having negative charge, then it is carb anion. So this is all about the heterolysis or heterolytic bond cleavage. Now we will talk about the reaction intermediates. The first point is that these reaction intermediates, they are formed in between the reaction. They are highly reactive and unstable species. They are formed during reaction but they never emerge as the main product. They are formed during reaction and converted to form main product. Their duration is very small, mean as they are formed, as they are very reactive, very well, highly unstable, so they easily get converted into some other form. Okay, so their duration is very small, means their half life is very small. Their half life is approximately equal to 10 to the minus 6 seconds. Okay, and they are highly reactive. And they are highly reactive. Okay. First intermediate is carb cation. Second is carb anion. C plus. Free radicals. Okay. Now, carb cation. It is an organic species in which carbon is having 6 electrons in the outermost shell. When carbon is devoid of its octet. In the outermost shell and having positive charge. Okay. Now, characteristics. Are of carbocation are as follows. First is it is having a positive charge on carbon. Second, it is electron deficient. And being electron deficient, it acts as electrophile. Okay. Electrophiles are Lewis acid. So it shows Lewis acidic nature. Electrons are paired. So it is diamagnetic. The carbon is sp2 hybridized. As it is sp2 hybridized, it shows planar geometry, and because of planar geometry, it is very likely to have racemization in stereogenic conditions and shows optical isomerism. Racemization in stereogenic conditions. They are usually formed in polar protic solvent and they are stabilized by electron donating group, means plus I effect. Okay, understood? So these are the characteristics of carpetions, that it is having a positive charge. It is an electrophile, electron diffusion, which is a Lewis acid. Electrons are paired and it is diamagnetic. It is sp2 hybridized, planar geometry, mean very likely to show racemization in stereogenic conditions. It is usually formed in polar solvent, okay, and it is stabilized by electron donating effect, that is plus I effect, plus positive inductive effect, right? Now comes carbonyl. It is an organic species in which carbon is having negative charge. Okay, carbonyl are electron rich molecules and being electron rich, it is having one extra lone pair. Okay, they have three bond pairs plus one lone pair. The carbon becomes sp3 hybridized. Now we will discuss the characteristics. First is the carbon is carrying 8 electrons in the outermost orbit. Means octet is complete. It behaves as a charged molecule. Okay, and this molecule is basically nucleophile. It behaves as a charged nucleophile. Okay, diamagnetic in nature. sp3 hybridization, but the geometry is pyramidal because of lone pair bond pair repulsion. Okay, next, geometry of allyl and benzyl carbanion is almost planar with sp2 hybridization. Okay, so these are carbanions. They react with electrophiles and stabilized by electron withdrawing group. And stabilized by electron withdrawing groups, यानी minus I effect. Now comes the free radical. The carbon free radicals are odd electron species. Okay, first point. Second, free radicals are the reasons a product of homolytic bond fission. Third, carbon contains 7 electrons in the outermost shell. It shows paramagnetic behavior as if they have an unpaired electron. They have sp2 hybridization and act as neutral electrophiles. Right? They are also stabilized by electron donating groups or electron releasing groups. Understood? No. So in this video, we will be discussing till here only. Okay. Then I will be discussing more of these effects, especially the electron displacement effects, in the next coming lecture. Till then, bye bye. Take care. Stay safe. Stay healthy.